So, welcome back viewers. So, in the previous lectures we are able to solve the linear differential equation, first order linear differential equation. So, today lecture will solve some important applications, and that we start with the first nonlinear equation, and that is Riccati equation, the very famous Riccati equation. So, like the Bernoulli equation, the Riccati equation is also highly nonlinear. So, the first order this is the first order nonlinear differential equation of the type y dash is equal to some px y square plus qx y plus some rx. So, where this function px, qx and rx, they are continuous function of x. So, in this case we have a y square, so that becomes, this equation becomes a nonlinear equation. Now, if in this equation I put r equal to 0, then if you can see from here, then this equation becomes y dash minus qx y is equal to px y square. So, that is the Bernoulli form with n is equal to 2. So, this is the Bernoulli equation for r is equal to 0. Now, for r is equal to not equal to 0, it becomes nonlinear and we want to solve these equations. So, however, the Riccati equation can be reduced to the Bernoulli equation if, so for r is not equal to 0, it can be reduced to the Bernoulli equation if one solution, say yx is equal to ux, is known. So, how to do that one? So, I will tell you the two methods to solve the Riccati equation. So, the first method is, so this is the first method. So, let yx is equal to ux is known. So, one of the solution is known to me. Then I take the transformation yx is equal to ux plus 1 over some zx, where zx is the, where zx is the solution of the reduced problem. So, now I will use this transformation to solve this equation. So, now my y dash can be written as u dash minus, so 1 over z becomes z dash over z square. So, y dash becomes this one. Now, substituting in the equation, that is the Riccati equation. So, I can give the name to the Riccati equation as r. So, now substituting this in the equation r, I can write that as u dash minus z dash over z square is equal to p u plus 1 over z square plus q u plus 1 over z plus r. So, this is the equation I got. So, from here I can have z dash over z square is equal to p, I expand this one. So, it becomes u square plus 1 over z square plus 2 times u over z, this, and this becomes q u 1 plus z plus r. Now, I know that the ux is a solution of, so I know that my u dash is equal to p u square plus q u plus r, because I know that this is one of the solution of the Riccati equation. So, if I have this value, then if you see, I can cancel out this term, this term, this term with this term. So, after cancelling this equation, I left with minus z dash over z square is equal to p over z square plus 2 p u over z plus q over z. Now, I multiply both sides by the z square, then I will get my z dash is equal to p plus 2 p u z plus q z, which can further be written as my z dash. So, this can be written as z dash is equal to minus p minus 2 p u plus q z, and which further can be written as z dash plus 2 p u plus q z is equal to minus p. So, this is the linear first order equation which we know how to solve, and once I solve this equation, I will get the value of z, and then putting the value of z, then I can define, I can solve, because u is already known to me. So, I know the u, I know the z, and then I can put back to the substitution and find the solution yx. So, let us solve one example. So, this is the example we are going to take. So, let us solve y dash is equal to y square minus 2x minus 1 y plus x square minus x plus 1. So, this is the Riccati equation we are taking. So, in this case, I want to solve this one. It is given that y equal to x is a solution of this differential equation. So, it is given to me, because I can start only with that if I know the one solution of the given equation. So, for the solution, so let us take transformation yx is equal to x, that is known to me, plus 1 over z, where z is the solution of the reduced problem. From here, I know that y dash will be 1 minus z dash over z square. So, if I doing calculation, will get, after solving this equation, in the here I will get the 1 minus z dash over z square. So, I substitute in the equation. So, it becomes 1 minus z dash over z square, the whole square, minus 2x minus 1, and my y is x plus 1 by z plus x square minus x plus 1. So, this is the equation we got. So, which can be further solved, and we are left with, after doing all the calculation and cancelling the terms, I will get this equation. So, this is the first order linear differential equation which can be solved further. So, from here my integrating factor is this. So, I can, in this case my integrating factor will be E dx. So, that will be Ex. So, from here my z, so z is a function of x, that we know. So, it will become -1 plus c e raised to power minus x. So, that is the solution of this equation. Now, I want the general solution of the equation of the given equation. So, the general solution is, I have Yx is equal to x plus 1 over z, and x is same, and z instead of z I can write this one value. So, that becomes g raised to power minus x minus 1. So, that is my general solution for the given Riccati equation. So, in this case I am able to solve the Riccati equation with the method 1. So, I have the another method, second method. Now, I take the transformation Yx is equal to some function Qx and then w dash over w. So, this is also a function of x, where, so in this case I take a function, non function Qx, multiply by w dash over w. So, this is my transformation, and w is the solution of the reduced problem, and Qx is some non function. So, now in this case I take the derivative. So, putting this in the Riccati equation, I get Qx w dash over w is equal to P Q w dash over w square plus Q w dash over w plus r. So, this one I getting, I am just substituting in the given Riccati equation. So, from here if I solve this one, I will get q dash by taking the multiplication w dash over w plus q, and then it becomes w square by w double dash minus w dash square. So, this is the derivative we have taken, and on the right hand side I will get the same factor. So, p q square w dash over w whole square plus q capital Q w dash over w plus r. Now, in this case if I simplify further, so I am doing the simplification. So, q dash w dash over w plus, so this can be written as q w double dash over w, because w will cancel out, minus q w dash square over w square. So, this becomes w dash square plus q w dash over w plus r. So, we are left with these factors. Now, if you see clearly from here, in this case if you see that we are going toward the second order differential equation, but we want to reduce the factors, because this is the problem, because we have a square of the w and w dash. So, now from here you can see that this factor and these factors can be cancelled out if I can choose my p is equal to minus 1 by q, because if I put p is equal to minus 1 by q in this factor, then this and this will cancel out. So, from here I have relation between p and q, that if I choose my p is equal to minus 1 by q, then this factor will be cancelled out. So, after cancelling this, we left with q dash w dash plus q w double dash is equal to q capital Q w dash plus r w, and it can be written as this one further reducing. So, I can write as w dash minus q q, then w dash is equal to r w. So, this is the linear second order differential equation. So, that we will going to do further in the next few lectures, that how to solve the second order differential equation, but this is another way of solving the Riccati equation. Now, so after solving this Riccati equation, which has a special form, now we start with another type of first order differential equation, a general differential equation, whether it is a linear differential equation or the nonlinear differential equation. So, let us take a separable form, separable differential equation, because till now we have solved the linear differential equation and we have solved some special type of nonlinear equation, that is the Bernoulli and the Riccati. Now, we move further and we will take a differential equation, first order differential equation, which is called the separable differential equation. So, let us take, I define a differential equation dy by dx is equal to f x y. So, this f x y is a function which has a function of x and y. So, let this function f x y can be written as some g x into h y. So, we can write this function as this one. So, I can say that my function on the right hand side is separable in the form of a function which is function of x only and multiplied by some function in the y, or I can write that I can have a function of this type which can be written as this form. So, in this case also I am able to separate the function in the function of x or in the function of y. So, once I know this equation, that this function is separable, and in this case I am not saying that this function f x y is a linear function, it can be linear and it can be non-linear. So, what I do is, once I have this value, so I can solve, suppose I take this function, form of this function, then I can multiply by h y both side and I will get g x. So, this is the factor I am taking. Now, so this I want to solve, which now I will try to solve this equation. So, this equation I want to put in this form, some form like some function of f y, and then so this one I want to solve. Now, what I do is I will integrate this one both side with respect to x. I have my h y dy by dx is equal to g x dx. So, with respect to x I am integrating. Now, what I do, I want to solve this differential equation. So, this differential equation can be solved because the problem here it is integrable, but how we solve this one? So, we further simplify this. Now, what I want to write this in the form of some function d by dx of f y x is equal to g x. So, this one I want to do, because in that case I am able to do that taking the derivative, and then by taking the derivative the solution becomes gx dx, and then I can solve this differential equation. So, how to convert this one in that? So, what you do is that I will define the function fy. So, this fy, the function I have taken, is the integration of the function hy dy, because if I choose this function as this one, then I know that if I take d by dx of yx, then it will becomes, so I am taking with respect to x, so it will become f yx with respect to y and then dy by dx. So, and this will becomes, so I am taking with respect to x now, so that becomes a function of x, function of y, sorry. So, now in this case I am going to do that. So, let us take one example, it will be more clear how to solve. I have a differential equation dy by dx is equal to x square plus y square. So, this is a nonlinear equations and this is a separable form. So, I can write that it is a separable form. Now, I can take y square, multiply both sides by the y square. So, I get y square dy by dx is equal to x square. Now, what I want, so this can be written as, I can write this one as d by y cube by 3 is equal to x square. So, what I am doing now, I am defining my function f of y is equal to integration of y square with respect to y. So, this is becomes y cube by 3, and if I differentiate this with respect to x, then I will get f of y with respect to x. So, this can be written as 3y square by 3 into dy by dx. So, this will cancel out and you will get this factor, and that is same as this factor. So, from here I am able to find my capital Fy, that is the integration of this. So, using this one now I have converted my differential equation into the simpler form, this one, and which can be further solved by taking the integrating both sides. So, if I integrate both sides with respect to x, then I will get y3 is equal to 3 is equal to, so this is equal to integration of x square plus c, and which can be further solved. So, y cube by 3 is equal to x cube by 3 plus c, and the answer of, so from here my solution is y cube is equal to x cube plus 3c. 3c is again one more c. So, that is my solution. And if I want to write this solution in the explicit form, so I can write that yx will be in this case x cube plus 3c power of 1 by 3. So, that is the general solution of that separable differential equation. So, we are able to solve the separable differential equation. So, let us take another example. I take another example dy by dx multiplied by exponential minus x cube equal to 0. So, in this case I have this factor exponential. So, I know that this is highly nonlinear. So, this is nonlinear differential equation. But so I want to solve this one, I do not know how to solve this one, but let us try to make it as a separable form. So, from here if I see this one, I can transform, or I can write this equation in the standard form, and this is the separable form. So, from here I can write dy by dx is equal to x plus x cube by e raised to power. So, in this case this is a separable form. So, once I am able to separate my right hand side function, then I can solve this one. So, I get this value. So, in this case I want to find my fy first. So, fy will be the integration of ey with respect to y. So, that will be ey, and from there I can say that so I can write that d over dx of f of y is equal to x plus x cube, where fy is this one. So, from here I can solve this one further. So, from here I can take the integration both side, and then my fy will be integration of x plus x cube with respect to x plus c constant. So, from here my fy I know this is ey. So, it can be written as x square by 2 plus x power 4 by 4 plus c. So, that is my solution, which can further be written as, I am taking the logarithmic natural log both side, and from there I can write my yx is equal to ln over x square 2 4 plus c. So, this is my general solution for the given separable form. So, using this one we are able to solve a nonlinear differential equation, but if the right hand side function is separable only. Now, we have another important classification of the differential equation, the first order I am talking about, and that is called the exact differential equation. Exact differential equation. So, in this case what I want is that if I have any differential equation and I am able to transform that differential equation in this form is equal to 0, where q is a function of x and y, it can be linear, non-linear, anything, then I know that from here I can integrate and I can show that this is equal to a constant. So, if I am able to transform a differential equation into this form, so this form I can write as a 1, then I can solve the differential equation. So, what is that? Our purpose is that whether we are able to transform the differential equation into this form or not. So, for example, I take an equation like this one, 1 plus cos x plus y plus cos x plus y dy by dx is equal to 0. So, this is the first order differential equation, and this is nonlinear because we have a cos terms for x plus y. If we expand that one, then we have a power of x and y. So, this is a nonlinear equation and I do not know how to solve this one, but if you little bit carefully look at this one, then you will see that this equation can be written as, it can be written as d by dx of this factor x plus sine x plus y is equal to 0, because if you take the derivative of this factor, then so where in this case I have my q and x y, this function as x plus sine x plus y. Okay. Now, if I take the derivative of qxy, then this will becomes 1 plus sin ka cos x plus y into 1 plus dy by dx. So, that will be my derivative, and this can be written as 1 plus cos x plus y, I am multiplying this one, plus cos x plus y dy by dx, and that is equal to 0. So, if you see this one, that this becomes same as this one, differential equation. So, it means I am from here, it means from here I can write that my differential equation becomes d by dx is equal to x plus sin x plus y equal to 0, and I can integrate both sides with respect to x, and from here I can get the solution that my x plus sin x plus y equal to some constant c, and that is my solution. So, this is the implicit form. In this case we are unable to write the solution in the form of explicit form, but here this is the implicit form. So, how means the next question is that whether we are able to convert all the differential equation in this form or not. So, there is a theory for that. So, what is our purpose now? Our main purpose is that suppose I have a differential equation, first order differential equation m xy plus n xy dy by dx is equal to 0. Now, the question is that whether we are able to convert this one into this form, d by dx some function xy equal to 0. So, that is my purpose, that whether I am able to solve this differential equation or able to convert this differential equation into this form, because if I am able to convert this one, then this is also solvable, very easily we can solve and we can find the solution for that. So, there is a theory behind that. So, let us define one theorem based on that. So, let m xy and n xy be continuous and have continuous partial derivatives with respect to x and y in some domain region R. So, R we define as some a b multiplied by c d. So, this is a region, square region, rectangular region. So, this is a rectangular region. Then there exists a function phi x y such that my m x y is equal to, this is equal to del phi by del x and n x y is equal to del phi by del y if and only if del m by del y is equal to del n by del x in R. So, if this is given, that if I have del m by del y is equal to del n by del x, then from these factors, these two equations, I can find the value of the phi, and once I am able to find the value of the phi, then I am able to solve this differential equation. So let us do this one for the proof of this theorem. So let us have differential equation plus dy by dx is equal to 0. Now, let there exist function phi x y such that d over dx phi x y is equal to 0. So, from here I take the derivative of this one. So, this is a total derivative. So, I know this derivative can be written as d phi by dx plus d phi d, because it is a partial derivative. So, I should write the partial form. So, it will be total derivative del phi by del x plus del phi by del y dy by dx equal to 0. So, if I compare this with this, from here I get that if I have this phi, then del phi by del x is equal to m and del phi by del y is equal to n. Now, I want to find, so from here I just solve this differential equation, this one. So, integrating both sides with respect to x. So, in this case integrating both sides with respect to x, I will get phi x y is equal to m. So, this is understood that it is a function of x and y dx plus constant of integration. So, in this case we have the partial derivative. So, the constant of integration will be a function of y, because if I take the partial derivative with respect to x both sides, then this will be 0. So, this is my, so I can write that this is my equation number 2. So, I have the solution of this one. Now, so this equation but from here I know that it is, let us do the next. So, but we know that del phi by del y is equal to nxy. So, from here I taking the again integrating both sides with respect to y, I can write that, no, but this is given to me. So, nxy is given to me, phi is also given to me. So, from here I can write del m by del y dx plus h dash y from here. So, because this is now I have this equation 2. So, what I do is that I differentiate this one with respect to y. So, if I take the differentiation with respect to y, what I will get, del phi by del y is equal to taking the derivative with respect to y, and this will be h y. So, this is written, and that is equal to nx. So, I have this factor now. So, from here I can write h dash y is equal to nxy minus del m by del y dx. So, this is a function. Now, what is this? It is a function of x, function of y, sorry, and on the right hand side it should be also function of y, because if we have the function of y on the left hand side, we also have a function of on the right hand side. So, this is possible this is possible if partial derivative with respect to y of the right hand side n x y minus del m y del y dx is equal to 0. So, because if it is a function of y only and I am taking the partial derivative with respect to x, then it should get the value of equal to 0. So, from here what I will get is that del n by del x minus so, I am taking this one. So, this will becomes del m by del y equal to 0, because here I am taking the derivative. First I am taking the integration with respect to x and then I am taking the derivative with respect to x. So, by the fundamental theorem of calculus I will get only del m by del y. So, that becomes this one. So, from here what I will get is that del n by del x is equal to del m by del y. So, now I get this one. Hence, if del n by del x is not equal to del m by del y, then there does not exist function f phi x y such that del phi by del x is equal to m and del phi over del y is equal to n, if it is not equal, right. But if it is equal to that one, on the other hand, if del n by del x is equal to del m by del y, then we can solve h y is equal to, that is the integration we have taken, del m by del y dx with respect to dy to find phi x y. So, so from here I can write that, so this is the statement I can say, the differential equation m x y plus n x y dy by dx is equal to 0 in some region R, in some region R, is said to be exact, if del m by del y is said to be exact if del m by del y is equal to del n by del x. So, this is the end of the proof. So, let us do one example. So, I want to solve a differential equation 3y plus e to the power x plus 3x plus cos y dy by dx is equal to 0. So, this is the differential equation I want to solve, and this differential equation has a factor cos y. So, it is a nonlinear equation. Now, if I compare this differential equation with the standard form, that standard form is mxy plus nxy dy by dx equal to 0, then from here I know that mxy is equal to 3y plus e raised to power x, and nxy is equal to 3x plus cos y. Now, I just want to check that whether, so what is del m by del y? So, it is 3, and del n by del x, it is also 3. So, in this case my del m by del y is equal to del n by del x. So, if this is equal, then I can say that this differential equation is a exact differential equation. So, if it is an exact differential equation, I can solve this differential equation. So, now from here, now I want to find a factor. So, from here one thing is true, that now I can write this differential equation to this form, d by dx phi x y equal to 0. So, this form I can find out. So, now I want to find what is my phi. So, to find the phi, so phi can be found. So, now we know that del phi by del x is equal to m, and del phi by del y is equal to n. So, that we know, because if I differentiate this one taking the total derivative, then and comparing with the differential equation, I can find that this should be equal to this and this should be equal to this. So, from here so now I have del phi by del x, and my m is ex plus 3y. So, that is given to me. Now, I integrate both side. So, integrate both side with respect to x. So, I integrate both side with respect to x. So, from here I will get phi of x y is equal to ex plus 3y dx. And now, integrating both sides with respect to x partially. So, I should write integrate both sides partially with respect to x. So, this is the, I should write clearly that integrating both sides partially with respect to x. So, if I do this one, I will get this value plus some function of y, because I am doing this one partially with respect to x. If I differentiate this one partially with respect to x, this will cancel out. So, from here I will get my phi x y, and now doing the integration partially with respect to x. So, it will be ex plus 3xy plus hy. So, that is given to me now. Now, so from here we know that del phi, this is given to me. So, del phi by del y is equal to n. So, this is equation I am taking with the double star. Now, we are taking, so from here, from the previous one I have that Ex plus 3xy is equal to phi. So, I have phi xy is equal to Ex plus 3xy and plus hy plus hy. Now, what I do is that, so I differentiate this one, differentiate partially with respect to y. So, I will get del phi by del y is equal to, so this will be a function of x, it will 0, it will be 3x plus h dash y, and this is given to me. So, and this is equal to 3x plus, so this is equal to 3x plus 3x plus cos y. So, that is given to me. So, from here I can compare and I will get h dash y is equal to cos y. So, from here I can get my hy is equal to sin y plus some constant of integration. Okay. So, from the equation I can define my function phi xy as Ex plus 3xy and hy is sin y and plus c. So, this is my given function. So, we are able to solve the differential equation of Riccati type, which is highly nonlinear. Then we are also able to the differential equation which has a separable form and the differential equation which has the exact form. Now, and it is independent that whether our differential equation is linear or nonlinear. So, in the next class we will discuss that how we can solve the differential equation of second order and the higher order, because in the today class, on the previous class we have solved all the cases of the first order differential equation. So, thanks for watching.